function y equals x squared after it has been translated down 2 units. So down is the variable d, and d is on the outside of the equation. So down would be minus 2. So not that one, not that one, that one. That's the only one that has minus 2. Left 3 units, it's essentially would be minus 3. So if you put in minus 3 in with the formula, that becomes x plus 3. So x plus 3, no, no, and there's the common mistake right there. Remember, in the formula, it has a minus sign there. Question number 2 was extra credit. Evaluate the piecewise function. We've never evaluated it, so I'll just show you how. Basically, put function notation above it, f, and then of x. That means your x value is 2. The question is, which one would you use for x equals 2, yellow or pink? Well, 2 is bigger than -1. So you would use the pink. And the reason why you don't use yellow, because 2 is smaller than -1, that is false. So -2 times 2 is -4. -4 minus 5 is -9 is your answer. If you graph this in yellow, 3x plus 1, you would start up here at 1, and then you would go a rise of 3, run of 1. But then you can also do it the reverse way, so that would be left 1, down 3, and you end up here at this open circle. The reason why it's an open circle, you can keep doing that, left 1, down 3 to give your points. And you're going in this direction because it is not, there's no equal sign, so it's an open circle. And it says less than -1, which means numbers that are less than are going towards the left. That's why you're kind of erasing the second part up here. -2x minus 5, if you're graphing this would start at -5. Slope of -2, so you would go down 2, right 1, down 2, right 1. Or you can go left 1, up 2. And the reason why I did that is to get a point here at -1, and then this is going to be a closed circle because you have an equal sign. So that's how you would graph the linear piecewise function. Question number 3 says match the graph by writing the appropriate basic function in the first blank and then the equation and function in the second blank. So graph number 1 here is a logarithm, or natural log. And if you wrote either y equals ln, that means natural log of x, or log of x, then you would have gotten 1 point each. Graph number 2 is a linear. It is y equals x to the first power. The third graph here is a rational function, or a reciprocal, and the equation is y equals x. Number 4, the name of the graph here is sine. Y equals sine x. The reason why you know it's sine is because it starts at 0, and its period ends at 0 again. Okay. Question number 4, graph the function. So let me put this in the graphing calculator, and basically so I'm going to clear that, x squared, 5 minus x, and then I do zoom 6, and that's what my graph looks like. I wrote over here my window that I changed it to, so -3, 6, scale of 1, y max I went to 40, and then every tick mark I wanted to count by 10, and the y scale counts by 5s. Got my graph. That's what my graph looks like. And then here I have a local minimum and a local maximum. So if I want to calculate those points, let's see where it's going to end up. So second, calculate. Let's do the minimum. So I can go to the far left over here, to the right of it, and exactly. Now, here is a graphing failure. Notice these numbers, and remember, e to the -7 just essentially means scientific notation, which basically means that you would move that, what's that thing called? The decimal left 7 times. and you would get a number like 0.0000655. What that essentially means is that number is essentially 0. And same thing with this one. So basically your order pair here is 0, 0 for your minimum. And I'll show you algebraically how to find that as well. To find your local max, same thing. Second, calculate max. Left side of the bump, right side of the bump, exact, and then I just rounded to the nearest tenths. 3.33, and then approximately 18.5. Okay? Alright, so in this problem I'm going to ask you, identify the interval. So intervals means interval notation. Which intervals is a function increasing, decreasing, or constant? So we start on the left side, control your person or an animal that you like, and you're going left to right. If you think about what's happening, your position is on the x-axis, and as you're going up and down, that's the y-axis. So if I start here, this is negative infinity, and the graph's going to go down to here, which means at this point, you're kind of falling, right? So that would be decreasing from negative infinity to 0. And you're actually going to stop at 0. And remember, we don't include 0, that's why it's a parentheses. And then it's actually increasing. Now, if you think about what's happening, the common mistake here is you're just focusing on the increasing, decreasing is focusing on the domain. And the domain, because we're going left to right, it's only referring to the x-axis, so you're only looking at the x-coordinate. So from here, 0 on the x-axis to here, which is around 3.33, it is increasing. And then from 3.33 all the way to this direction, it is decreasing again. So I wanted to highlight that answer. So your two answers would be that one. Now, for the constant, there is none. A constant would look like this, straight line. Okay. Now, I also would have taken that at these points right here, it is also not moving. It's not increasing nor decreasing, so you could argue that our minimum and maximums are constants. I would have accepted that as well. That question was 1, 1, and 1, so only 3 points, and then 1 point for the graph. To find this algebraically, how you knew this was 0, 0, and your calculator gave you the wrong answer, you could have done the zero product rule. Set each of those equal to 0. And then if you solve this, you just add x to both sides, you'll get x equals 5. So this one, we don't need that. But we do need this one. Take the square root of both sides. X is equal to a plus or minus 0. There's no plus or minus 0, so it's just x equals 0. Okay? That side was, let's see, 4, 8, 12, 12, 12, 12, 14, 16. 16 points. I don't think that's right. Backside. Why something messed up on this one. Let's see if I can use color coding. So find the following below with their domain. These are called function compositions. Every time you see f of x, or every time you see the f, we're going to write x minus 3. So let me do that for all of them. F of x, x minus 3. And you should be doing your substitutions there. You can see in parentheses. And then every time we see g of x, we're going to write x squared plus 9. G, 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 x squared plus 9. And anytime you evaluate or you're going to do a substitution, you need to put them in parentheses. So students who got this problem wrong got no parentheses. I put in my substitutions there. Notice here this is a plus sign, so you don't need the parentheses. Drop them, combine like terms. X squared plus x plus 6. And the domain is negative infinity to positive infinity. Let me explain that. You're supposed to find the least restrictive domain. Find the parent, right? You're a kid. You're trying to go around your parents. You're going to ask the parent who's more lenient, right? So if you need money, go to the one who usually gives you the most money. So notice how these parents or these domains are exactly the same. So then your least restrictive domain is just this, negative infinity to positive infinity. For question number B, remember the substitution is in parentheses, and when you have the subtraction sign, it's a -1. So you have to distribute. That would become negative x squared, and this would become a -9. And when you combine like terms, you get negative x squared plus x and minus 12. Same thing with the domain of negative infinity to positive infinity. Question number 6. Question number 6, you don't have a math operation, so it's multiplication. It's f times g. When you do that, you can use FOIL or the box. Here's my box. Same thing, you're going to multiply first. And then you're going to combine like terms. So that becomes x cubed, 9x, negative 3x squared, negative 27. Same thing. Which one has the least restrictive domain? It's negative infinity to positive infinity. Basically, if you think about it, your domain is going to be the same as both of our original functions, unless you do division, which is question number 6D. When you're dividing here, notice how I don't need my parentheses, so I can drop those. X minus 3 over x squared plus 9. I would consider factoring x squared plus 9, but this is not a difference of squares. Okay, now what do you do? Well, you need to set that not equal to 0 to find your domain. If you subtract 9 and then take the square root, your answer is x equals plus or minus 3i. This is a complex number, so you have a complex solution for your domain, which means that you could pick any real number. You could pick any number in there, and it's never going to be undefined. Does that make sense? You could pick a negative number, positive number, or 0, and then you still get a number, so the domain is negative infinity to positive infinity. For question number 7, I had to give it back to you guys because I wasn't really clear on my directions, so we pass it back, and I told you guys, based on its symmetry, find the inverse. I told you to find inverse algebraically. How do you find the inverse algebraically? Well, basically for every x value, you put in negative x. Negative x squared is negative x times negative x, which is x squared. That becomes negative 2x and minus 1. If you got this but didn't make any notations, I gave you 3 points. If you did a substitution negative x, I give you 2 points and 1 point if you wrote neither but no work. How do you know the answer is neither? Well, if it was exactly the same as the original, it looks close, but your negative sign here and a plus sign here, that means it's not an even. If I factor out a negative one, let's factor out a negative one. Negative, so that would be negative x squared plus 2x plus 1. Remember, just reversive distribution, positive, negative, negative. Inside the parentheses, does that look like the original problem? The answer is no, so it's not odd. The answer is neither. Question number, which I told you guys to change, should be 7b. How do you prove that graphically? Well, if you graphed in your graphing calculator, you'll notice that the vertex here is not on the y-axis. So a lot of students try to put it directly on the y-axis. It's not. It looks like that. Let me show it to you. Y equals x squared plus 2x minus 1, zoom 6. Boom. It's not symmetrical. Okay? So, I know it's not symmetrical about the y-axis. It doesn't fold exactly. It's not symmetrical about the origin. Remember, the origin is the ones that graphs looks like this over here in quadrant 2 and then quadrant 4 or quadrant 1 and 3. So the answer is neither, because it's not symmetrical evenly nor it's not symmetrical odd or even, therefore it's neither. If you wrote, I give you 3 points if you wrote neither but no explanation. 2 points if you have a graph that was correct, and if you have an incorrect graph, I give you 1 point. Question number 9. Find the x and y-intercepts from the following function. I give you a rational function. To find the x-intercept, you're going to make y equal to 0. Remember, you change the f of x into a y. You make the y equal to 0. How do you make 0 a fraction? You put it over 1, so you can cross multiply. 1 times this expression is just this expression. 0 times this expression equals 0. Subtract 1, x equals negative 1. So there your order pair, negative 1, 0. To find your y-intercept, make x equal to 0. 0 plus 1 is 1. 0 minus 5 is negative 5. 1 divided by negative 5 is negative 1/5. So your y-coordinate is negative 1/5. Your x is 0. Those are your two intercepts. To give you guys partial credit, I give you 3 points for one of those were correct. 2 points, maybe I need ask you to show more work. And you can actually use those in the next problem. Question number 10. Graph the function and make sure to include asymptotes and a table of values. The bad thing is if you just put this in your calculator and just copy the graph, you didn't know how to do that. To find a vertical asymptote, you're going to take the denominator and set it not equal to 0. Add 5 to both sides. X cannot equal 5. And that looks like on my graph where all your x values is a dotted line. The horizontal asymptote here, how do you find the horizontal asymptote? You're going to compare the highest degree from the numerator and denominator. So you have numerator to denominator. And there I have a 1. 1 equals 1. Now when they're equals, all you have to do is reduce. So you look at the numbers in front, the coefficients, and when you reduce those, you get 1. So that's why my horizontal asymptote is 1. Okay, so how do you get a table of values? Well, we know that x here is equal to 5. Okay, this yellow line right here. So let me see if I can put that back on. And visually, if this is x equals 5, I need numbers to the left of 5. Do you see how it's numbers to the left of 5? And the numbers to the right of 5? Well, we can just put that in our calculator, so let's do that together. Put it into your y equals, clear it. I'm going to put an extra set of parentheses, x plus 1, x minus 5. And then, I mean, you can take a look at the graph, zoom 6. And then what I'm going to do is to get my table of values, I'm going to go to second window to set up my table set. I do want it to be auto and auto. I want the table to change by ones just because I'm having them by ones here. And then I'm going to go to the table, so second graph. And then I just copy those numbers. I kind of picked 4 numbers to the left and 4 numbers to the right of it. So starting at 1, and you can just copy down those numbers. And you'll see there at 5, it says error. That's our vertical asymptote. And basically the table of values proves to us kind of you didn't just copy from the graphing calculator. So when you graph that, right 1, 0.5, right 2, negative 1, right 3, negative 2, right 4, negative 5. So my graph should kind of go up a little bit higher, but you get the idea. Then undefined there, and then 6. What you're finding is basically is it above or below that pink line? That's basically what it is. Right 6, up 7, 7, 4, 8, 3. So you recognize that it's approaching that pink line. Right 9, up 2.5, and then you can just draw your smooth curves. That side was out of 24, and I think it was out of 40 or 41. Whatever it says on Aries. Hopefully that was helpful for you. Good luck.